Welcome to The Explainer. So, today we're digging into this really fascinating report that kind of pulls back the curtain on AI memory. We're told that these large language models are just getting bigger and better, with memories that can hold millions and millions of words. But what if that's not really the whole story?
I mean, it's the big question right now, isn't it? You've got models like GPT-4 and Gemini 1.5 boasting these massive, million-token context windows. And the promise is, hey, you can feed it a whole novel, and it'll remember every single detail. But it turns out, when researchers really pushed these models to their limits, they found something very different.
All right, so let's just tear into this myth. I mean, the promise is incredibly compelling, right? Just give an AI a huge amount of information and it'll use all of it perfectly. But the reality, as this research shows, is, it's a lot more complex and honestly kind of messy.
So here's what we think should happen. We expect an AI's performance to be this perfectly flat line, that it handles the very first word just as well as it handles the millionth. But the reality? It's a steady downhill slide. The longer the input, the less reliable the model gets. And the researchers, they have a name for this. They call it context rot. So what exactly is context rot? Well, it's the official term for this breakdown, this degradation of an LLM's performance and reliability as you keep feeding it more and more information. To put it simply, the more you stuff into the AI's brain, the more forgetful and unreliable it can actually become.
Okay, so to figure this all out, researchers at Chroma came up with a series of really clever experiments. They started with that classic needle in a haystack test, the one where you hide a piece of information in a huge block of text and ask the AI to find it. And then they cranked the difficulty way up.
So the first thing they did was introduce what they call distractors. And you can think of these as little decoys, bits of info that sound a lot like the right answer, the needle, but are totally wrong. It's a way more realistic test of an AI's actual reasoning skills. And this is where it gets really interesting. The immediate impact was huge. Just one of these distractors caused a noticeable drop in performance. But when they added 4 of them, the model's accuracy just plummeted. I mean, just look at the chart here. You can see exactly how steep that drop is, especially as the text gets longer and longer.
And what's fascinating is that different models fail in totally unique ways. Take the GPT family, for example. They would often just make something up, a really confident-sounding answer that was completely wrong. But then you have the Claude models, which were way more conservative. If they were uncertain, they'd just refuse to answer at all.
So that led the researchers to the next logical question. Does it help if the haystack of text is, well organized? I mean, intuitively, you'd think a coherent essay would be way easier for an AI to navigate than just a jumble of random sentences, right?
And to test this, they did something really clever. They had the model's performance on the original, coherent essays, and then they compared it to the exact same text, but with all of its sentences randomly shuffled. They basically created topical gibberish.
And the result? It was genuinely shocking. Across all 18 models they tested, performance was consistently better on the jumbled-up, incoherent text. It's wild. It seems that the logical flow of a normal document might actually be a distraction, making it harder for the model to spot that one out-of-place needle.
All right, so let's bring this into a more realistic scenario. Next, the researchers tested a chatbot's ability to remember key facts from a really long conversation history. Something we all just assume our AI assistants are great at.
And check this out. When the models were just given the relevant facts they needed, what they call a focused input, they scored super high, no problem. But when they had to find those exact same facts buried inside a long, messy chat history, the full input, their performance just collapsed. The simple act of searching for the information made them fail. Think about that.
So for the final test, the researchers stripped everything away. No complex reasoning, no information retrieval, nothing. They just asked these incredibly powerful models to do one super simple thing: copy a long list of repeating words. That's it. Just copy them exactly.
And the result was a spectacular failure. Just look at this number for GPT 3.5 Turbo. It refused to do the task a whopping 60.29% of the time. And get this, it wasn't because the task was too hard. It was because its own internal safety filters got confused by the simple repetition and flagged it as potential spam or harmful content. Wow.
And then other models failed in these downright bizarre, almost human-like ways. I'm not kidding. This is an actual quote from the QN3 model when it was asked to do that simple copy task. Instead of just doing it, it basically said it needed to, quote, chill out. Just
Amazing.
So this all leads to a really crucial point. If just making the AI's memory bigger isn't the solution, then what is? And this brings us to a really fascinating new field that the researchers are highlighting. It's called context engineering.
So what does context engineering even mean in practice? Well, as this research shows, it's all about being way more deliberate. It means carefully cleaning up the information we give the AI, getting rid of those confusing distractors we talked about earlier. It means understanding that something as simple as putting the most important fact at the very beginning or the very end of a prompt can make a huge difference. Basically, it's a huge shift from just dumping more data on the AI to giving it smarter data.
When you get right down to it, this report completely shatters that myth of a perfect photographic AI memory. It shows us that these tools are, yes, incredibly powerful, but also surprisingly fragile. The real answer isn't just building bigger and bigger models. It's about developing better techniques, like context engineering, to actually guide them. It forces us to move past the hype and start thinking more like architects of information, not just users. And that really leaves us with a critical question for the next frontier of AI.